In this video, we'll be looking at quadratic equations and how we actually find the values of x or the roots of the quadratic equation. We could actually do this at least in three different methods. We can look at what we call the quadratic formula, completing the square, and also quadratic equations. And so the first thing that we're going to do, we'll probably look at the other methods in other videos, but we were looking at quadratic equations, and so probably we'll look at using the quadratic formula and completing the square method to do the same thing. And so today we'll be looking at how we solve quadratic equations. Very, very simple. And so let's go. Let's say we have a quadratic equation looking like this. Oh, bear in mind, some persons probably don't know what's a quadratic. Well, a quadratic equation is an equation that has 2 or square as the highest degree, or the highest degree. Some might call it index, some call it powers, some call it exponent, and so on. And so the highest degree is a 2. And if you should look at it, let us look at the quadratic in the general form. Let's say we have ax to the second power plus bx plus c is equal to 0. And now this is similar as the quadratic expression when we never had any 0 there with any equal. But in this case we have a 0. And so this is the standard or the general concept or formula for let's say the equation for a quadratic equation. And if you look the x's, look at the x's, you only have 2 x's, and this x as a square, and this square is the highest degree. Here is just a 1. This is a constant, and so we don't have any variable per se being attached to this c, which is a constant. And so if I were to just write an equation that's somewhat samples this, or copies this, I could write an equation looking like, let's say, x squared plus let's say 6x plus 5. Let us try to understand these terms in the equation. Well, this term represents this entire term. And if you want to look at it piece by piece, let's look at it. Remember that any term that you see, like a variable by itself, and you're not seeing a visible coefficient there, we always have an invisible 1 as a coefficient. And so if you should look at it, this a would represent that 1, this x could represent that x squared, this b represents the 6, and this x represents the x, this c represents the 5, and 0 represent it. And so we can see that each term in this equation is corresponding with its term that is in the general formula. And so how do we solve a quadratic equation? Well, what will be the values of x? Well, if we remember how to factorize a quadratic expression, then we are good to go. What we call the AC method. And so the AC simply be multiply the coefficient of the x squared and then multiply it by the constant c. The answer that we get, we find 2 factors of that answer. When we multiply them, we get back the same AC as a product, but when we add them, we will get the middle term of this equation. So let's go. What would be our A and what would be our C? Well, our A would be 1, as you can see. Our A would be 1 and our C would be 5. So if we say 1 times 5, this is the A times the C. That gives us 5. If we should find out the factors of 5, we get 1 and 5. Now, what 2 factors of 5, when you multiply them, you get back 5, but when you add them, you get 6. Well, only these two, we don't have any more. So what we do, we just expand this equation by substituting 1 and 5 in terms of x to replace 6x. So we will have, well, I normally tell my students, well, you can just try to write them in such a way that you match a term with another term that you can easily factorize. And so let me just show you what I'm talking about. So let's go up. So let's rewrite this. So we have 1, no, that's not what we want. What we have, x squared plus, I'm going to put, I'm just going to put 1 right here. Or I can just write x. There's a coefficient of 1 right there. The coefficient of x is 1. And so if I actually write this, I have now 5x plus 5 is equal to 0. And if you look at these two can easily factorize. These two can easily factorize. And so I always say rearrange them or to substitute them in such a way that you can factorize a term with another term. But if you had written it another way, if you could have written it like this, it wouldn't make a big deal. If you had written it just like that, it wouldn't make a big deal. We still could factorize this, and we could factor that. Well, 1 would be the highest common factor for both, and so on. So it wouldn't be any big deal. And you know that we replace these, because these are the two factors that we got from 5. When we add them, we get 6x. We must write them in terms of x. So because you have 1x plus 5x's give you 6x's, and so we can see that it is substituting the x in an expansion form. And so let's go ahead with the rest of the working out. Alright, so we want to say now we will just group these two. Group these two, group these, group that, group that, group that. And then we say, what is common in this? Then we say, what is common in this bracket? Well, what is common in this bracket? You could say an x is common. So if I should divide this x into that and the x into that, x into this goes x times and x into x goes 1 time. What can be factorized from this bracket? The highest common factor is 5, and so we pull 5. Or when you get the highest common factor, what you do, you normally take the highest common factor and divide each term in the bracket, and then you put your answer right here in this bracket. And so if I say the highest common factor will be 5, so if I divided 5 by this, 5 cancels that, the x all by itself, I put the x there, 5 into 5 goes 1 time. And so we'll actually see that we have 5 outside, open bracket x plus 1, close bracket equals 0. What you should always pay attention to, ensure that the two brackets are identical at the end of your factorization. And so after that, we just group what is outside, and then we just take any one of the brackets. So we group what is outside. So x plus 5, close bracket, and then you take any one of these brackets and put it beside it. It doesn't matter because they are identical. And now we actually factorize this. This brings us to how we factorize an expression. Well, we were not introduced to how we will factorize a quadratic equation. So what we now want to do is to equate these two brackets to 0. And so we say x plus 5 is equal to 0. Let me just draw a line here, and then we're going to do this bracket with 0 as well. X plus that is equal to 0. And then let's solve for the value of x. We could say what number when you add with 5 you get 0. What number you add with 1 you get 0. Or you could just simply do a transposing here. So we could just make x a subject, we subtract both sides by 5. That cancels that. X is all by itself. And we say 0 from 5, 0 minus 5 gives you back -5. You could do the same thing with this, minus both sides by 1, and we say that cancels that. X is equal to 1. So our answer is actually x is equal to -5, and this is not writing properly, and -1. And so these are the solutions of the the quadratic. These are the numbers if you should actually plug them one by one into the original function and you evaluate it, you will get 0 as the answer. So that's it. Now we could actually use the quadratic formula and complete the square to get the same answer. And so the thing is that this method does not work all the time. The AC method does not work all the time, because sometimes you want to factorize or you want to solve the quadratic equation by using the AC method, and it doesn't work all the time. So when it doesn't work, what do we do? Well, we're going to look at that in the next video.